Welcome everybody. This is the first class on integration. I will be starting off with basics and then slowly gravitating towards higher intensity problems. Now this particular course on integration is very important for any science and engineering. Suppose you want to get into any streams in science or any streams in engineering, integration is the integral part. Now more specifically, if you want me to correlate the benefits of studying integration to the existing scenario, then fields like data sciences, data analysis, machine learning, financial engineering, all of these areas require integration. So that is for the motivation for this subject. So having mentioned that, let me start off by giving the formulae. These are the important formulae that you will have to know. The first one is integral x raised to the power of n dx. This is equal to x raised to the power of n positive 1 divided by n positive 1, positive arbitrary constant. Now this is called as arbitrary constant. Now if you do not place this arbitrary constant and you have just placed this value, the solution is considered incorrect. In other words, the solution is not complete, so you will not be awarded full marks if you miss this. Some of the professors or lecturers, they are very strict. The minute they see that you have missed the C, they will simply mark it wrong. So this arbitrary constant is important. So let me move on to the next formula. Integral dx over x, this is equal to ln, you need to place this modulus of x in this fashion, ln of modulus x, because ln is only defined for positive values and it is imperative that this quantity is positive, so the modulus sign is important. Now if you do not place modulus, again you will be marked wrong. So question number 3, or I would say formula number 3, integral e raised to the power of x dx is equal to e raised to the power of x positive arbitrary constant c. Now let me draw a line and put in 4. Integral a raised to the power of x times dx. This is equal to a raised to the power of x over ln a positive arbitrary constant c. This is a very important formula. Formula number 5, integral of sin x dx. This is equal to negative cos x positive arbitrary constant c. Now some of you would slip or skip this sign. If the sign is missing, your solution is wrong. So have that in mind. Question number or formula number 6 is integral cos x dx is equal to sin x positive c, arbitrary constant c. Formula number 7, this is going to be integral of secant squared x dx is equal to tan x positive c, and let me place formula 8 there. Integral of cosecant squared x dx is equal to negative cot x plus c, and 9, integral of tan x dx is, now this is a very important formula. Now let me just show you. I know that integral of tan x is sin x divided by cos x dx. Now if I want to integrate this quantity, I will use the technique what is called as technique of substitution. So what do we do here? We take cos x to be equal to t, we differentiate cos x, we get differential of cos x is negative sin x dx. This is equal to dt. So sin x dx is negative dt. So if I were to substitute that value, this is going to be, in place of sin x dx, I substitute negative dt. In place of cos x, I substitute t. If I were to integrate this, I get negative ln t. Now you might be asking me, okay, I will just place negative ln of modulus of t, and then I will say negative ln of, now I'm removing this modulus sign, and then I would be placing cos x. The fact that I'm able to remove, because we are not dealing with definite limits, we are only dealing with indefinite limits, so that gives me that extra privilege of removing it. Of course, it is a good practice to write it in this fashion, ln of modulus of t. That conveys to the examiner that you know the concepts well. Now this is negative ln of cos x, and what you can do is you can retain the modulus. Just to be consistent, I will just retain the modulus sign, and then I will place the arbitrary constant c. So that is the solution for integral of tan x dx. Now if I were to extend this line and then go up to formula number 10, I've got what is integral of cot x dx. Now this is going to be ln of sin x plus arbitrary constant c. Now if you want me to show you how it is done, now cos x is nothing but cos x over sin x times dx. Now let me take the substitution of sin x being equal to t. I differentiate, I get cos x dx is equal to dt. Now if you were to substitute that, cos x dx, I get dt over t, and this is going to be ln of modulus of t, which is nothing but ln of modulus of, my value of t is sin x, so that's why I get ln of modulus of sin x plus arbitrary constant c. So that's why we got that value. Now the next one, question, or I would say formula number 11, integral of secant x. This is a very important formula. Secant x dx is equal to ln modulus of secant x positive tan x positive arbitrary constant c. We will see how to get these things. And integral of cosecant x, this is also a very important formula. Cosecant x dx is equal to ln modulus of cosecant x negative cot x positive arbitrary constant c. Now having given you 11 and 12, let me also squeeze in 13. Integral of secant x tan x. Secant x tan x dx is equal to secant x plus arbitrary constant c. So that is also a very important formula. Now having given you this, let me move on to give formula number 14. This is going to be 14, integral of cosecant x cot x dx. This is equal to negative cosecant x positive arbitrary constant c. So I've given you 14 formulae over here, and after these 14 formulas, let me just flip the page and give you the other set of formulas too. Now this is number 15, integral of dx divided by square root of a squared negative x squared is equal to, very important, sine inverse of x over a positive arbitrary constant c. Number 16, integral of dx divided by a squared plus x squared is equal to 1 over a tan inverse of x over a positive arbitrary constant c. Now you need to know that over here we don't have any 1 over a being multiplied, but over here we got 1 over a, so exercise some caution. Formula number 17, integral dx over x times square root of x squared negative a squared is equal to 1 over a secant inverse of x over a positive arbitrary constant c. So I will be stopping here as far as the formulae are concerned. I will be stopping here, and then I think this is sufficient. So I've given you 17 formulae, and with these 17 formulae we will be able to handle things.